To Waidsum Academy. Today we're looking at geometry. And in geometry we're looking at the first part, which is the area and circumference of a circle. Okay, we've learned a circle in our earlier stage. We said a circle is a length that is wound round, okay, to touch. Where it starts from, it meets it back in a circular manner. So a length that has been wound round, okay, is a circle. Now that length itself that has wound round is called the circumference, and the space inside is called the area. The space inside is called the area, and this area can be calculated for this lower level to be pi r square. The area can be calculated of a circle can be calculated to be pi r square, while the circumference, which is the length that is wound round, is 2 pi r. It's 2 pi r. R is the radius of a circle. What is radius? If you draw a line across the center of a circle from the beginning to the end, it's called the diameter, like this one, D, diameter. Now if you divide diameter into 2, it becomes radius. One of it becomes radius. For example, here to here. So from the center of the circle to any part of the circumference is radius. This, from here to here, from here to here, and from here to here. From the center of the circle to any part of the circumference is called the radius. But before we move further, please let's listen to this tutorial.
So here we're looking at how to work with the formulas for the area and the circumference of a circle. And for a circle of radius r, the area is pi r squared and the circumference is 2 pi r, or possibly pi d, where d of course is 2r, so that makes perfect sense. Now one thing people get confused with is which formula is which, and always remember that the units of area are squared something. So squared is always area. So pi r squared is area. So in the normal problem solving sort of way, write down what you know and what you want to know, or at least be very aware of what those things are. Pick the correct formula, pi r squared or 2 pi r, and substitute and solve or whatever you have to do, and just make sure that you don't confuse radius and diameter. Other than that, just follow your nose. So let's have a quick look at a couple of questions. We've got a path around a park, and it consists of 2 straight lines, there they are, and 2 semicircles at the end. And we'll note that the radius of the semicircles is 36.6 meters. And we're asked to find the length of the path to the nearest meter. Okay, so what is the length? The length is, well, it's going to be 2 times the straight bit plus 2 times the distance along the semicircle, and that of course 2 times the semicircle is 1 circle, okay, and that is going to be 2 pi r. Now do we know what's what? Well, we know that r is 36.6, and so we can now just do 2 times 85 plus 2 times pi times 36.6, and that is 399.964 something something something, which to the nearest meter is of course 400 meters. We're then asked to find the area enclosed by the path, this time to the nearest square meter. Now it's always a good idea to write down what we're doing, so I'm going to say the area is a rectangle plus, well, it's 2 semicircles again, and this time 2 semicircles, well, they make a whole circle, and this time that's pi r squared. Now what about this rectangle? Well, its width is the diameter, which is 2 times the 36.6, and so the area of that rectangle is its length, 85, times 2 times 36.6, and we have to add the area of the circle, and that's pi times 36.6 squared. And if I stick all that in my calculator to the nearest square meter, that comes out at 10,430. Okay, one more question. not too difficult. Here we have two circles, both with centre O. They're known as concentric circles. And the area between them is shaded, and that's the area we want to find. And notice that we are asked to leave our answer as a multiple of pi. Well, the area is going to be, and again, just telling the examiner what I'm doing is good, the area of the big circle minus the area of the smaller circle. And we know we're going to use pi r squared here. Do we know the radius of the big circle? Well, that's 3 plus 2, so that's 5 centimetres, and the area of the little circle is that 3 centimetres. So it's pi times 5 squared minus pi times 3 squared, which is 25 pi minus 9 pi. And if I've got 25 pi's and take away 9 pi's, I'm left with 16 pi's. And so there is my answer.
Okay, so we just listened to that tutorial which will solve the basic questions that this chapter attains. So all we need to do is to do more questions. We've already explained that the circle, the area of a circle is pi r squared, and that r is the radius. That's from the center of the circle to any part of the circumference. From the center of the circle to any part of the circumference. From the center of the circle to any part of the circumference is the radius. Now 2 radius is equal to diameter. So a radius plus a radius is a diameter. So diameter equal to 2r. Diameter equal to 2r. Or r equals to diameter divided by 2. R equals to diameter divided by 2. So we can show this. We can show this by saying if we have a circle, okay. Okay, here is a circle. Okay, here is our circle. Here is the center of the circle. Let's assume here is the center of the circle. So if I draw a line from here to this part, any part of the circumference, it's called the radius. It's called a radius. If I draw another line, you get another radius. Okay, this is another radius. But if I continue this line, this will become a diameter. This will become a diameter. This will become a diameter. So we call here D diameter, and we call here R. We call here D diameter, and we call here R. So we already know these basics. So we say the area of a circle is equal to pi r squared. The area of a circle is equal to pi r squared. The area of a circle is equal to pi r squared. Now the circumference is this line. This line that forms the circle. This whole line that forms the circle is called the circumference. So this circumference is equal to 2 pi r. 2 pi r, or what you call pi d. 2 pi r, or what you call, because 2r equal to diameter. 2 times r is diameter, so we can say the circumference is also equal to pi d. The circumference is also equal to pi d. Okay, so in that case, if that is so, now let's move on and see. These are the basic things we need to know about this, okay? And then the next is to jump into solving questions. Say find the area of the perimeter. Find the area and the perimeter of the semicircle shown in the diagram. So give your answer in terms of pi, meaning you don't have to write the value of pi. So 3.142, just write pi. You say find the area of this. Okay, this semicircle, so we can say the radius. To find the radius, we say 16 because this is the diameter. 16 is the diameter. So to find the radius, we're going to say 60 divided by 2. Okay, we're going to say 60 divided by 2. So to find the radius, Okay, let's assume this is our semicircle. Let's assume this is our semicircle, and here is 16 centimeter or meter, whatever it is, 60 centimeter, 60 meter, okay, whatever it is, that's not a big deal. Now we want to find the perimeter and the area of this circle. So we say radius is equal to diameter divided by 2, diameter divided by 2, which gives us 16, 60 divided by 2, which gives us 8 centimeter. So the radius is 8 centimeter. So if you're looking for the area, okay, before we do the area, what is the area and perimeter? Perimeter is the total distance around the circle. So here we have the half of arc, the arc of half a circle. So it's like we're going to find the semicircle arc will be C divided by 2, right? So which is 2 pi r over 2. To find the value here, 2 pi r divided by 2. 2 pi r, which is the circumference of a circle, divided by 2. So if we divide by 2, we just have pi r. And they say we should leave our answer in terms of pi. So we say radius is 8. 8 times pi is 8 pi. So we get our semicircle, this circumference, this arc, to be 8 pi. Okay, and we have here to be 16. So to find the perimeter, we will add this diameter plus this arc. So perimeter will be our diameter we just have, which is 16. You know, perimeter is the total distance around the object, plus the C over 2 that we just found, the arc of half a semicircle. So we say 16 plus 8 pi. 60 plus 8 pi. Is that okay? 60 plus 8 pi. So that will give us our perimeter of this circle. What about the area of a circle, of this semicircle? So we say area is pi r squared. Since this is a semicircle, it's not a full circle, we divide it by 2. So pi r squared divided by 2 we'll get for semicircle in this regard. For semicircle, when we divide it by 2, we get for semicircle. So they say leave our answer in terms of pi. The radius is 8, so 8 square pi. 8 square is 64, not 16. Okay, divide by 2. So this gives us 64 pi. 64 pi divided by 2. So when we divide this by 2, we get what? We'll get 32 pi. So our area of this shape will be 32 pi in terms of pi. If not in terms of pi, you say 32 multiplied by 3.14, and then you get your final answer. This is area, we put centimeter square. If it's in centimeter, we put centimeter square. Okay, this will be our answer for this question. Is that okay? Now let's move on. So see, 32 pi for semicircle, the area of a semicircle. Area of a circle is 64 pi, which we obtained, and the area of a semicircle becomes 32 pi. So area of that shape is 32 pi. Okay. Okay, the perimeter, we solved the perimeter, 8 pi plus 16. We solved the arc, the curve length to be 8 pi, and we know the diameter to be 16. So 16 plus 8 pi gives us the perimeter of the circle, which is what we have solved already. Is that okay? Which is what we have solved already. Okay, which is what we have solved already. Okay, let's move on. Now let's go to arcs and sector. Okay, before we proceed for arc and sector, let's listen to this tutorial. Let's listen to this tutorial before we proceed for arc length and the area of a sector.
So here we're going to look at working with sectors of a circle, looking at both the area of it and the length of the arc at the end. The arc is this curved bit here. So this sector, looks like a slice of pizza, is a sector of a circle, and the formulas are very like the formulas for the area of a circle and the circumference of a circle. You will remember that the area of a circle is pi r squared, and we just want a fraction of that, and there are 360 degrees in a circle, and the fraction we want is theta. If the angle here is theta, theta 360ths, and that will give us the sector area. Similarly for arc length, the circumference of a circle is 2 pi r, and we want the same fraction, theta out of 360 of that circumference. Occasionally people have a difficulty remembering which formula is which for circles. Well, just remember that all units for area are squared, square centimetres, square metres, etc., and so squared is area. As ever with problem solving things, write down, or at least make sure you are aware of what you know and what you want to know. Pick the correct formula, again remembering that squared is area, and then substitute, solve, etc. And you shouldn't, and I hope you never will, confuse radius and diameter. So let's have a quick look at a question. OAB is a sector of a circle, and the angle at the centre of that sector is 50 degrees, and we're told that the area of AOB is 20 pi square centimetres, and we're asked to find the radius. So that's the radius there, OB, or indeed OA. We know the area is 20 pi, and so we want to write down the formula for the area of a sector. So area is equal to theta, which is 50 over 360 times pi times, well, r squared. But what is the area? Well, that's equal to 20 pi. So here we have an equation to solve. We just need to find r. Now the first thing we can do, let's make our lives simpler by cancelling the pi's. We're allowed to do that, and then I can do a fair amount of simplification here. I can divide both sides by 10 to cancel there, and then if I multiply both sides by 360 over 5, why would I do that? Well, I'm trying to get rid of 5 over 360. If I do that, I get r squared equals 2 times 360 over 5, which is 144. You might take a couple more steps to do that, but that's fine. And square rooting gives me r equals 12, and it's in centimetres. So we've used the formula backwards, as it were, but as ever, we've just written down the formula and put in the numbers we know. Now we're asked to find the arc length, and the arc length is, well, it's just theta over 360, so that's 50 over 360 times 2 times pi times 12. Okay, I've used the radius very carefully there, and if I put all of that in my calculator, I get 10.5 centimetres to one decimal place, as I was asked. And there we go, that's sector area and arc length.
Okay, so we've learned to find the area of a sector, the arc length, and what have you. And we've also written down the formula. Okay, that if you're given a circle or a sector of a circle, not a full circle, a sector, just a sector. So let's say, for example, we have this, we have one radius, this is another radius, and then there is an arc. Okay, there is an arc. Let's change. Let's say there's an arc here that joins from this point A to point B. This is an arc. Okay, let's say this is O, center O of a circle, and this is A, and this is B. Okay, now here is the radius of the circle. Here is the angle. Normally we call theta. This is the angle. So if you are asked, this is a sector. This is a sector. It's not a full circle. If you want to draw a full circle, you're going to see it continue. You're going to continue. A full circle is going to continue, you know, it's going to continue like this. So this is just a fraction of a circle. A fraction of the area of a circle. That's what we call the area of a sector. It's just a fraction of the area of the circle. So this is just a fraction, one fraction of it. Okay, you have maybe other 3 or 4 other fractions of it. So that's why if you're looking for the area of this sector, we can shade it. If you want us to shade it, you can shade it. You can make this one so conspicuous as area. Okay, this is the area of the sector, this space that you're looking for. Okay, this is called the arc length. This one, we call it L, arc length. Okay, so if you're asked, you want to find the area of a sector, this sector, AOB, area of sector AOB. Okay, this is sector AOB, sector, area of a sector, not area of a circle, because it's not the full circle, it's just a small sector of the circle. Area of sector AOB is the angle, this angle, theta over 360, whatever you call the angle, even if you call it x, you say x over 360. If you call it theta over 360. Why do we say 360? Because the angle of a circle is 360. So you're just looking for a fraction of it, times the formula of the area, because you're looking for area of a sector. You're looking for area of a sector. Area of sector AOB. Area of sector AOB. So since we are looking for area of sector AOB, we simply say the fraction, this angle over 360 times pi r squared. Because, why do we use pi r squared? Because the formula for area of a circle is pi r squared. So you're just looking for a fraction of the area of a circle. Okay? Then for the arc length, we're saying this length, this arc, the length of an arc, this arc, the length of this arc. Okay? If you're looking for the length of this arc, then the formula will be, so we write arc length or length of an arc, arc length is equals to also a fraction of the whole length of the arc of the circle, of the whole circumference, because you're doing only a part of the whole circumference. Similarly, you will say theta, because you do a fraction of it, theta over 360, the angle over 360 times, because this is about circumference, you are looking for a part of the circumference, you say times pi, 2 pi r, times 2 pi r. So these are the formulas we need to cultivate how to use, the habit on how to use. Okay, that's that for that. Let's move down. It's just for us to take a problem and solve the problem. For example, you say AOB, this is O. O is the center of the circle. AOB is a sector of circle with angle 42 degrees as shown. Now the area of the sector is 28 centimeters squared. Find the radius of the sector, give your answer in 2 decimal places. So they've given us this, and they've given us the area to be 28 centimeters squared, but they want us to find the radius. Sometimes they will give you the radius, they want you to find the area. So you should be very conversant with how they play. No matter how they play, you should be able to know how to play as well. Okay? So now let's take a look at that. Let's say we have a sector. We have this sector, and this angle is 42 degrees. This angle is 42 degrees. They want us to find this radius. And they say the area, so I write a sector. Sector as a small subscript. So a sector, meaning area of sector. A sector is equal to what? Is equal to, we write the formula. A sector is equal to what? Theta over 360 times pi r squared. Anything area, you put pi r square. So the theta is 42. So we write 42 over 360. 42 over 360 times here probably we use the value of pi, right? Because they did say leave the answer in terms of pi. So we use the value of pi 3.14 or 3.142 times r square. We're looking for r, right? We're looking for r times r square. So is equal to, because they're giving us the area, they say it's equal to 28. Is equal to 28. Is equal to 28. So I can multiply both sides by 360. If I multiply both sides by 360, I will eliminate this denominator. Okay. So if I multiply here by 360, if I multiply the left side by 360, I multiply the right side by 360. Okay. So this 360 we cancel this one. So we say 42 times 3.14. 42 multiplied by 3.14. What do we get? 42 multiplied by 3.14. What do we get? 131.88. You say 132 approximately. 131.88 r square. Okay, equal to 28 times 360. 28 multiplied by 360, what do we get? 28 multiplied by 360, what do we get? We get 30,080, right? We get 30,080. Okay, so we divide both sides by this number. So we divide both sides by 131.88. So we divide both sides by, divide 10,080, divided by 131.88. 131.88. What do you get? We approximate to the nearest whole number, whatever we get, or 2 decimal places as the question has demanded. So r square, still this is r square. R square gives us 76.4, right? 76.43. Now arrow means we find the square root of this number. Arrow means we should find the square root of this number, 76.43. The square root of that number gives us what? Is it 8 point something? Root 76.43. What do you get? 8.74. 8. Remember they say we should leave our answer in 2 decimal places. So 8.774. Yeah, because the next digit is not up to what we can approximate. So this will be our radius, 8.74 centimeter. This will be our radius. So this is how we apply this formula to solve any problem, okay, of area of a sector. So this is what they got, 8.743, but you have to approximate to 2 decimal places, you get 8.74. Is that okay? So that's that. Then the B part of the question says find the length of the arc, giving your answer correct to the nearest whole number. Now that we have found this, find the length of the arc. You say calculate the length of the arc. This one, this length, this one. Calculate the length of this arc. Okay, so now length of an arc, let's do it here, the B part of the question. Let's shift it to this side. Okay, this one was A part of the question. B part of the question, we change the color, make it a bit orange. B part of the question. So you say length of an arc is equal to the angle theta over 360. The angle theta over 360 times 2 pi arrow, times 2 pi arrow. Okay, so remember we've just found the radius. Since we've calculated the radius, It is that radius we just found that we're going to use. So length of an arc will be 42 over 360. 42 over 360 times 2 times 3.14 times the radius we got, which is 8.74, right? 8.74. So key this into calculator. Key this into calculator, you get 42 divided by 360 multiplied by 2 multiplied by 3.14 multiplied by 8.74, we'll get 6.404, which is approximately 6, okay, to the nearest whole number. So we'll get 6.4074. 6.4074. So to the nearest whole number, this will give you, the length will be 6 centimeters to the nearest whole number. This will give us 6 centimeters, okay, as the question has demanded. So this is how we apply this chapter or this topic. I think we're done with this part. Next class we will take the application of this area of a sector and circumference of a sector.